this is my SOS signal light. You can see that when I push the button, the device does function and it displays SOS for a limited period of time. Eventually, the loop in the code will end, the LEDs will go out, and you'll have to push the button again to reactivate it. So it doesn't stay on long term. There aren't different settings, there's only one. You push the button, the SOS flashes for a limited period of time. But you can see it is quite bright there, and it is working nicely. Now, there are a few major components here. We have the Arduino board, we've got a 9-volt battery and battery clip to power it. We've got 3 yellow LEDs, a mini breadboard which was sawed in half so it fit inside the casing, a push button and a pull down resistor, and the circuit will not work without the pull down resistor. If you take that resistor out, the LEDs will just flash on and off. So that was really important to the success of the circuit. Now let's look at the casing. We have a 3D printed main body. This comes in 2 parts, the back, which is deeper, so you can put the components inside, and then the top of the casing, which you'd flip over and place over the top of the components. Now let's look at the casing. We have a carry handle here, but you can see that it's designed for 4 fingers, but you can only really get 3 fingers inside. 4 is a bit of a tight fit, and the finger dividers are quite angular, quite sharp. It's not very comfortable to hold, so work needs to be done to refine this. On the main body here, you can see there's this cutout, and the idea here is that you'll get like a rubber membrane, maybe a piece of a pencil case, like plastic pencil case. You could cut a circle out, put some hot glue here, and glue a plastic or rubber cover, and then this could go over the top, and you'd be able to tap here and feel the button underneath and push that push button that we see here on the main circuit. And by using hot glue, you'd be able to make this waterproof, so water wouldn't be able to seep in here. So we've got 3D printing, carry handle's not great. Obviously, this isn't finished. There's a reason for that. I didn't bother putting the top on because we have a major issue here. You can see that the wires extend quite far from the components, which means that I can't close this up without damaging the wires, which would then stop the whole thing working. So I've got 2 options here, really. Well, 3. I could redesign the whole thing and make something completely different, or I could extend the width of the whole device, but then it would become a box rather than something thin and handheld. So that's not ideal. So the other option would be to take these wires out, trim them down to make them much shorter, and then refit them across the circuit so that they're tight and flat across the Arduino. That would take a bit more time and a bit more effort, but that might be able to solve this problem so that I could get the case over the top. I'd be able to push on there and touch the button underneath, which right now isn't possible. So the other problem as well with this casing is that to make it waterproof, I talked about waterproofing this, but to make the rest of the case waterproof, I need to seal this section off and stop any liquid, any moisture getting through, so like rain and seawater and things like that. So to do that, I could simply hot glue all of this. But if I do that and seal the unit, when the battery runs out, you just have to throw the whole device away, or you'd have to break open the casing, which would ruin the whole device. So it's not very eco-friendly, it's not really recyclable, so there's a flaw there. Now what I could do is have some kind of clip mechanism and maybe some kind of rubber cover around the side, but I've not researched how to do that and I haven't done it. So right now I can waterproof it, but that would mean that it's a single-use device. Once that battery dies, that's the end of the device. Now I used a laser cutter for the acrylic casing on the top. I used a rectangle which I curved using a heat gun, so I heated the acrylic and then I just curved this round very carefully, and then I cut this flat part with the laser cutter, and then I just hot glued all of this, and I could put hot glue all around here and here, and I could seal that up. Now I've only made a cross section for this example, but the idea is that this would be one piece, like a cap that goes on top, and that would be easy to make, but I only made half of it for the sake of this example. So the major issues there are the lack of waterproofing and the fact that all of these wires stick out. So I would hot glue the Arduino board in Right now, the battery, it doesn't have a compartment or a clip or anything. All you have here is some blue tack to hold it in place. So not the most elegant solution, but it does allow you to replace the battery. I used the adhesive pad on the back of the mini breadboard to stick that to the casing. Like I said, I'd use some hot glue, but even now with the blue tack that I've used and the adhesive pad, I can shake this, turn it upside down, and then when I push the button, it should still work. So you can see the LEDs are coming on there. So giving it a shake doesn't really make any difference to the functionality of the circuit. So that's good. Now, how far away would we be able to see these 3 LEDs from at night or in poor visibility conditions? I don't know. I'd have to test it. Probably not too far when it's only 3 LEDs. And it's much harder to see them from the side than it is from the front. They're much brighter from the front. So we've got the use of 3D printing. We've got some laser cut sections. We have some examples of soldering here where I soldered the jumper wires directly to the resistors and then onto the LEDs. That way I didn't have to put as many connections on the breadboard. So now the digital pins go directly to the LEDs rather than to the breadboard and then onto the LEDs. So that saves space internally. So that's it. That's the SOS signal light. I'm going to ask you to look at the rubric and grade this device. I'm interested to see what grade you'd give it. And that's it. My SOS signal light. Working, but I don't think it's perfect. So you grade it and tell me what you think and what you would give it.